Null hypothesis testing, or everything I need to know about science I learned from Scooby Doo. Scooby Doo and the gang never meant to become detectives. They were just driving around in their mystery machine when the van happened to have a flat tire in front of an abandoned amusement park. It could happen to anyone. But fortunately for us, Scooby, Shaggy, and the gang knew a thing or three about the scientific method. When they heard there was a ghost trying to scare people away from the abandoned amusement park, they had to investigate. And there are two hypotheses they could use. The null hypothesis is that there are no ghosts. The alternative hypothesis is that there are ghosts. So which is the one to use? How to explain these strange happenings? Which explanation to start with? If they started with the assumption that there are ghosts, then the show would be rather brief. They would see something that looked like a ghost, take that as evidence of ghosts, and then paddle-foot it out of the amusement park. But by looking for clues, they discover what is really going on. Once unmasked, however, ghost explanations are not required. The answer is never ghosts. And it's not because scientists hate ghosts or that our minds are closed to belief in ghosts. It's because we're skeptical, critical thinkers. We are open-minded, but don't be so open-minded that your brains fall out. Zoinks! As G.K. Chesterton once said, the object of having an open mind is the same as that of having an open mouth, to eventually close it on something. If scientists are said to be closed-minded, it is only because we are reasonably sure that we understand a phenomenon. Yes, the answer could be ancient aliens, but I'm pretty confident that it is not. As Geddy Lee said of Tom Sawyer, his mind is not for rent. So the wisdom of Scooby is this: all the real monsters in the world are human, and everything supernatural or otherworldly is just some jerk trying to scare you so they can make money. And this is why we need inferential statistics. We need a way to scientifically determine which explanation is most likely, chance or an effect. Does this outcome, sample mean, more likely represent the population defined by chance? Or does this outcome, sample mean, more likely represent the population defined by an effect? Inferential statistics are used to determine the likelihood that the sample data, M, mean of the sample, represent a particular population mean, mu, or not. By represent, we say that the sample mean is really close to the population mean, plus or minus some random sampling error, which of course is caused by chance. Descriptive statistics, you may recall, are used to describe the sample data, i.e. the mean of the sample. So we use descriptive statistics to describe the sample, and then we use inferential statistics to determine the likelihood that the sample mean represents a population mean. So now it is time for a proper definition of hypothesis testing. Hypothesis testing is an inferential statistical method that uses sample data to evaluate assumptions about a population parameter. Okay, that's a mouthful. Let's break that down. Inferential. We make an inference, or an educated guess. Statistical method. Hypothesis testing is a technique with 5 steps. Just like following directions to assemble a bookcase, you will follow these same steps every time you do hypothesis testing. Sample data. That's the mean of the sample that we tested. Sample mean. Population parameter. Well, that's the mean of the population. And to evaluate an assumption, our assumption, the hypothesis that we're testing, is that the sample mean and the population mean are the same. We will evaluate an assumption using a 5-step method to make an inference about whether the sample mean represents the population mean. And that is hypothesis testing.